Good evening, everybody. Tonight's lesson is over Chapter 1, Section 7. You're going to title this lesson Order of Operations. Now, you guys have been doing Order of Operations since 6th grade at least. Started out learning, please excuse my dear Aunt Sally, parentheses, exponents, multiplication, division, addition, and subtraction. Now, we're going to take what you already know and just extend it a little bit more to make it more fitting for what we learn in algebra. So now I just want to show you guys that we're going to expand what we think of as parentheses to now calling that more of grouping symbols. So you're going to see in algebra this year a lot more than our basic parentheses. You're going to see brackets. You're going to discover that up in this top layer of order of operations, the P, the grouping symbols, we're also going to include absolute value bars. So anytime you see absolute value bars, you want to treat those as first order of business, as grouping symbols or parentheses. You're also going to see fraction bars. When you see fraction bars, you're going to treat those as grouping symbols or that first level. When we do exponents, E, you also now need to think of E, exponent, as including square roots. So if you see a square root in your expression, you're going to treat that as the second level under exponents. Multiplication and division are that next level. Remember that it can be multiplication or division, whichever comes first from left to right in your problem. That's why I drew this arrow up here, from left to right for multiplication or division. Doesn't matter which one, I put them on the same level. The final level is our addition or subtraction, whichever comes first in your expression from left to right. Okay, so same principles as when you learned order of operations in 6th grade. Now we're just going to take it a step further. So I'm going to give you quite a few practice problems in this lesson. I want you to write them all down, even if you know them, just so you have them to refer back to for when we do a lot of practice in class. Just remember what an exponent is. Remember the vocab that goes along with exponent. In this problem, we have 3 to the 5th power. The 3 is the base. The exponent is the 5, the little number, and then the power is the whole thing. It's the 3 to the 5th power, okay? The power is both the base and the exponent together. 3 to the 5th power means take your base, 3, and you're going to multiply it by itself however many times the exponent tells you to. So 5 times, I'm going to write this 3. That's what it means. Keep in mind, it does not mean 3 times 5. That is absolutely not what it is. It's 3 times 3. Take that answer times 3, that answer times 3, that answer times 3. Okay? Now, one thing that I just want to refresh your memory on, is there a difference between this negative 4 squared and this negative 4 squared? Do they give you the same thing or do they give you different results? Let's take a look. When the negative 4 is not in parentheses, as is the case in the first one right here, negative 4 squared, what this means, that negative sign outside of the 4 simply means the opposite of 4 squared. Well, 4 squared is 4 times 4, 16. The opposite of 16, guys, is negative 16. So that's the result when I take this problem right here and I read that out loud, the opposite of 4 squared. Compared to this next expression where my negative 4 is in parentheses. Those parentheses make a huge difference. That means I'm squaring what's in the parentheses, which is negative 4, which gives me negative 4 times negative 4. Well, negative 4 times negative 4 is positive 16. So did those parentheses make a difference? Absolutely. So pay close attention to that in the problems to come. Here's 2 problems. Write these down in your journal and we're going to work them out. Okay, I'm just going to explain bits and pieces of it because I think a good portion of this problem is going to be review. The only thing that's a little bit different compared to what you learned in 6th grade here is that negative 4 squared that we just talked about, the opposite of 4 squared, which gives us a negative 16. What would come next at this level? Negative 16 plus 24, the addition? the division or the multiplication? We want to take care of the division next because that's what comes first from left to right. It comes before the multiplication of 3 times 2. So I do 24 divided by 3 to get my 8. Now I need to decide what comes next. I would know that would need to be my multiplication step. Last is going to be my addition. So that's the answer you should get, 0. The next problem, we have a grouping symbol here, multiple grouping symbols. We have our brackets, which we are going to need to be worried about. So I want to take care of what's inside my brackets first. Looking at what's inside these brackets, I see I have another grouping symbol, which is my parentheses. So I've got to start there first. Okay, it's like its own order of operations problem inside our bracket. So I'm going to take care of my parentheses first. 5 minus 2 gives me 3. What comes next, the subtraction or the exponents? The exponent. So I need to do 3 squared, which gives me 9. Now take care of your subtraction, and then it isn't until our very last step that we get to take care of that multiplication of the 4 that was on the outside of our grouping symbols to produce 4 times 16, which is 64. Here we have an absolute value problem. We need to take care of our absolute value first because that is part of grouping symbols. Inside our absolute value is an exponent, so I need to really do that first. 5 squared gives me 25. 10 minus 25 is negative 15. Now I take the absolute value once I've gotten it all the way down to just that one integer. The absolute value of negative 15 is 15. Now I can do the division, 15 divided by 5 to get 3. Here we go. We have a division problem here, a fraction bar. I wrote you a note that the fraction bar acts as a grouping symbol. So we're going to simplify the numerator first, then simplify the denominator, then do the division last. So looking at the numerator, what are we going to take care of first? I see an exponent. So I'm going to take care of the exponent first. 2 squared gives me 4. So negative 22 minus 4 is in my numerator. My denominator simply has 5 minus 3, which is going to give me 2. Negative 26 on the top divided by 2 gives me 13. Okay, work these out in your journal. Don't just take my word for it. I want you guys to work them out step by step and make sure the goal here is that you end up with the same result that I do. If you don't, you need to ask about it in class. Okay, here we're going to evaluate an expression. We've done this before, guys, where we take a value that they gave us. Here they want x to equal 7, and we're going to substitute that 7 for x in our expression. So I'm just going to rewrite the problem, but instead of the x, I'm going to replace the x with a 7. Now follow order of operations. Press pause. Work this out yourself. Press play. Make sure you get 24. Next problem here, I have a square root symbol. Remember what we said, square roots follow in the same category or level as our exponents do. So I'm going to take care of that first, okay, because I don't have parentheses, so I move on to my next level and take care of what's inside our square root. 3 squared is 9. 9 minus 5, I'm going to take the square root of that. 9 minus 5 is 4. So I have the square root of 4 divided by 8. Square root of 4 is 2. 2 divided by 8. I could rewrite this as 2/8, which gives me what? 1/4 would be my answer. That's a fraction. 2/8 is the same thing as 1/4. We always want to simplify our answer. So in closing, I want you guys to think about this. What role does order of operations play in writing or simplifying algebraic expressions? Why do we have order of operations? What's the point behind it all? Think about that. Write down your own answer in your own words. This is my answer. Order of operations is used to give us a sequence in the mathematical process. It gives us a formal sequence that we can use in solving problems in our process of mathematics. That's it, guys. See you later.